Thank you very much, Homer. Thank you all. I want to actually thank David and the ITP because in 1988, I was offered the chance to be a visitor in a program at the ITP before it was called the KITP. It was a formative experience in my career as a junior faculty member. It gave me time, energy, and connections to accomplish a lot early on in my career, and it was important in my professional development. I trust that there's some of the KITP visitors, postdocs here, enjoying similar opportunities. Take advantage of them and enjoy your time in this beautiful place. I certainly am. We have about 12 or 14 inches of snow on the ground right now. And the airport, I believe, is probably closed, but we'll see if I can get back tomorrow. It is truly a pleasure to talk about this subject of diversity and excellence in physics. It's something that I've thought a lot about, and as your department chair in physics here, Omer, has mentioned, something that physics departments, academic institutions are coming to realize is a great opportunity for us. And so I will share with you some of my thoughts and experiences in this issue, how I came to be interested in it, and some of the things that we have done in my time at MIT. To begin with, let's level the playing field by just defining terms, because these often arise in the discussions about this subject, diversity, inclusion, and excellence. It's important to make some distinctions here. Diversity is obvious. Variety is a synonym for it. There is the definition from the Merriam-Webster dictionary, and I would not differ with that. There is great variety in this room. In fact, this is a remarkable physics audience, a remarkably gender-diverse audience. It is probably primarily a U.S. domestic audience. I'm contrasting, and I'm here perhaps guilty of stereotyping and drawing conclusions based on appearances, but if I compare this with an audience in my physics department at MIT, we have more than half of our faculty are international born, and more than half of our graduate students are international born. And so I believe that there would be some alternative kind of variety in that audience to what's reflected here. We're aiming for excellence as physicists, as educators. And this is achieved not through diversity alone as a goal, but one of the primary goals that I try to foster, and many of my colleagues do, and you as well, is through inclusion. Inclusion, I like very well the definition here from social psychologists, a sense of belonging, feeling respected, valued for who you are, feeling a level of supportive energy and commitment from others so that you can do your best work. Before I was the department head, I was I was the division head of astrophysics at MIT, where I played the role of shepherding junior faculty and graduate students within the astrophysics division of my department. I found it very rewarding, both for me and for the junior faculty, to devote time and effort towards mentoring them. I was doing exactly what's described in this language of inclusion, valuing people for whom they are, providing a level of supportive energy and commitment so that those faculty and students could do their best work. I truly believe that that kind of support and caring for people helps them to perform their best regardless of their background, but especially those who see enormous challenges from lacking role models and from being underrepresented in physics. The definition of excellence given here is a tautology. And so therefore I'm free to define it how I want to. And really, the goal, one of my goals, has been to use these three elements together in a constructive way to bootstrap what is sometimes a vicious cycle of decline into a virtuous cycle of improved excellence through increasing diversity and that inclusion. And you'll see that there's some cyclic order here in the sense of the arrows. I do believe that inclusion facilitates excellence and that the connection with diversity is two ways. I asked myself, indeed, people asked me when I became the head, and since, why am I thinking about this issue and devoting energy to it? For me, there are three answers. One is that it is a smart thing to do. When I became the head, I noticed that we were receiving many fewer applicants for a graduate PhD program than were showing up as first-year graduate students at Harvard, actually. And that was less surprising, perhaps, even, than the fact that some of those Harvard students would then come do their research with MIT faculty. And I thought to myself, why is it that we are educating Harvard PhDs who don't come to our department except to do their research and then get the credit of a Harvard degree? That just doesn't make sense. So it was logical, therefore, that I should spend some time looking into this and asking what can we do to gain more credit for the students who go to Harvard and want to work with MIT faculty. Let's recruit them ourselves. Second reason for me is that it's the right thing to do. I see increasing diversity and inclusion in physics and in science, technology, engineering, math fields, STEM fields, as a matter of social justice. Perhaps that goes back to my roots growing up in a Hispanic neighborhood in Southern California. Perhaps it's reflected in my undergraduate and graduate days when I was a member of the National Organization for Women. Whatever it is, I believe that it's right to give others the opportunities that many of us had and the encouragement to help them succeed. So those are some of the personal reasons that I have brought to it. And quickly I realized the third reason was that I could do something about it. That I was in a position as a department head with enough respect from my colleagues, from my students and others, so as to make a difference. I think all three reasons might have some relevance for everyone in this audience. Well, I'll give you some other reasons that I articulate to my faculty. And what I'm giving you today is an expanded version of a talk I've given to MIT physics faculty a couple of times. This is a gallery of faculty hired at MIT since I began. It's a diverse group, both gender diversity, diversity of fields, and diversity of national origins. I trust that some of these people are known to some of the physicists here. They're very high quality bunch of people. If our department, or yours for that matter, were viewed as one that is unattractive to a particular group for whatever reason, then you don't have access to some of the talent in that pool. And they may be just the people that you want to hire. Very importantly for us a decade ago, and I understand now for you in the Santa Barbara Physics Department, is concern about student enrollments. You see that 10 years ago, as the technology bubble began to take students out of math and science and put them into computer science and electrical engineering, and perhaps for other reasons, we had a rather steep decline in the numbers of our undergraduate students. This is bachelor's degrees per year awarded in physics at MIT. There was great concern about this trend because you could extrapolate it. We noticed not only is there a negative slope, but there's a negative second derivative. And by 2004, my previous department head, or maybe me at that time, would have been out of a job because our dean would be asking, why do you have so many faculty members when you don't have any students? Well, our department head at the time, Mark Kastner, was concerned about this and noticed that his daughter had just begun the Harvard physics program and was very excited about the program. She graduated in physics, and he found out one of the reasons for Harvard's success was that they weren't putting quite as much pressure on the students in terms of the number of requirements, the intensity of courses, the pace and pressure that so many of us have experienced and think it's natural to transmit to our students. And so he put forward what in retrospect was a modest proposal to the faculty, to our executive physics council. Namely, that we would take 3 of the upper division courses these students take, 3 of the gateway onerous courses to graduate school, because after all, this was a graduate school preparatory curriculum, and allow the students to form a concentration in any coherent set of subjects they wanted to. Could be science, could be social science, anything they wanted to. Kind of like having a minor. In fact, as you'll see, one of the consequences was that many students used this as a vehicle for double majoring. But the effect was that we reduced the intensity, the pace and pressure on the students a little bit, opening up the opportunity for students to flow into physics. And he sold this to the faculty by pointing out that with this change, we would still have one course requirement beyond Harvard's honor track. So it was good enough for MIT, and you see the outcome. Okay? We have roughly doubled the number of graduates per year, and this was in 2001. We introduced this flexible degree track. We've also significantly increased the gender diversity of our undergraduates. We introduced this flexible track. We call the other one the focused track. Our conception was that the... Please, interrupt. Please, go ahead.
So, do you increase the number of applications, or do you increase the applications?
There are no applications to undergraduate physics. This is just recruiting students from the incoming freshman pool. We don't admit students into majors at MIT. All the freshman students take the same curriculum. Of course, many come in with an idea of specialization. But as you'll see, we're drawing students into the major even after the first year. And plainly, the students found it a more attractive option to go into physics with this extra flexibility. And most students have taken advantage of that to double major. They're not slackers, by the way. But so the blue is the male and the red is the female population. There's a further subdivision, which is a little hard to see here, into kind of a crosshatched, which is this flexible track versus the more focused one. We thought the focused one would be graduate preparatory for physics, and the students choosing the other option would do a variety of careers. We were wrong. Actually, most of our students continue into graduate school in physics or related fields, and with, I think, rather similar breakdowns between those two populations. Much of our growth in numbers has been powered by women. You can see that roughly 50 plus or minus 10 majors per year have been men, but now the numbers of women are growing. They exceed 20. This year, I hope that we will have more than 40 women graduates with physics degrees. We're on track for that. Of course, institutions like to look at the national rankings in various ways. One way is to look at the production of undergraduate degrees. This ranking is a bit skewed by the fact that our department, like yours, combines physics and astronomy, whereas Berkeley, for example, has a separate astronomy department. Were you to combine physics and astronomy at Berkeley, they would exceed us. But we certainly produce a large number of physics degrees, and Santa Barbara is in the middle of this pack. Now, this is a very interesting plot for us because the degree, what's powering some of the degree growth is not just that one step up introduced by the flexible major, but there is a continuing increase, for example, in the size of our sophomore class. Our students typically declare a major at the end of their freshman year. The junior class roughly tracks the sophomore class, lagged by a year. So there's a little dip here, which shows up there, which shows up there. This is the senior class at the top. And you see here we have a huge step up in our senior class this year. In fact, in that class, currently we have 44 women. And typically we have a few percent attrition in the senior year from the numbers who are registered in the fall, although it is not gender imbalanced. So I'm hopeful that we will break the 40% mark for our graduating physics class this year. That will be a milestone for us.
So if I understand this, people are declaring physics majors in the senior year?
Yes, exactly. You see there's a big step up here. This is not, for example, fifth year students. No, this is not super seniors. These are students who in their junior year realize I'm getting a degree in electrical engineering or mechanical engineering, and by taking a couple more physics classes, I can add physics.
So I have to just clarify, your focus track
No, our focus track is unchanged from 2000. Our flexible track is the one that has 3 fewer upper-level physics subjects. That's right.
Have you seen any difference in the GRE physics performance of those 2 cadres?
I haven't looked at it, so I don't know. I don't know.
That's often where some of those issues pop up in terms of when they're taking the important results of the GRE.
That could be, and some of the entry into this senior year is from students who don't intend to go on to graduate school in physics, but take advantage of the flexible program to add the physics degree to their CV. Yes?
Have you interviewed students to ask them why they chose the stuff they did and why they decided to sign up for physics to compare with
I have not personally and systematically interviewed students, although we do have a senior survey that we conduct every year. And of course, I read the survey responses and have a sense from about a half of the students respond to that. Students are drawn to physics because of the reasons that we all are drawn to physical sciences. It's intellectually challenging. It's an opportunity to learn about nature at its deepest level. And in our case, the students are drawn both by the attractiveness of the degree program and the quality of teaching. We get very strong praise for our classroom teaching, and oftentimes we'll draw students in the freshman year, sophomore year, who wouldn't have thought to go into physics, but they so enjoyed their beginning classes. Yes?
So at the risk of drawing this out maybe part of it is warranted, it comes from what you just said, is that the change is not answering the number of students who are interested in this, but rather the number of students who decide not to pursue it.
I'm not sure I quite understand. We have made an effort to attract students to physics. In particular, I have written letters, as Lars knows, to high school students who are promising in physics and encouraging them. It didn't work. His daughter is majoring in mechanical engineering, but she did come to MIT. But that's a small percentage of our growth. I think a lot of it is students who didn't think of themselves as physicists until they really got hooked with the subject. And I didn't mention this verbally, but I want to emphasize this bottom point that we now have more physics graduates than biology graduates. That is a huge thing. Nationwide, there are more than 10 times as many biology bachelor's degrees awarded each year in the U.S. as physics. We have more physics graduates at MIT than biology.
The biology has a real That's not a factor of 10.
Biology is suffering some loss to a new bioengineering department. But I also think that some students want to do, for example, biophysics and see that a physics preparation helps them. I wanted to do astronomy and astrophysics, and I got a physics degree because it was helpful. I didn't go to an astronomy undergraduate program.
Did the number of students with physics as their sole major increase?
Probably not. I'm not sure I have here the graph of single versus double majors, but I don't know that I have data to answer that question on the breakdown of single versus double. But for sure, the number of double majors grew substantially. And frankly, a big part of this growth in the last year is that MIT changed the way that it does the double majors so that they have now to earn fewer total units. So some of this growth is just from the fact that it's easier to get a second major. I would say probably not all of it, though, because look at these trends. And that's really wonderful. There aren't very many universities that show this kind of sustained growth in the major. It's causing us some strains. We have more majors per faculty member than we have had certainly in 50 years and probably ever. We have classroom capacity issues, teaching, scheduling, the same issues that you have here for perhaps some of the reasons, perhaps different financial reasons. But those are good problems to have. It's better to have students coming into the major. Are there other questions on this? Yes, Phil.
Pursue that question a little bit, because if we made it substantially easier for people to add physics as a degree, then I suspect they would take advantage of that, because students normally see it as advantageous to have multiple degrees.
Right. One way to rephrase your question is, are there more of our graduates going on to graduate school in physics, just numerically, than before? Yes, resoundingly yes, absolutely. The percentage going on to graduate school in physics and related fields is comparable to what it was 10, 20 years ago. Yes?
So do you know if the graduate schools that accept these students view these subjects with flexible majors differently?
What do the faculty here say? I can tell you that I've had senior thesis students of both varieties in all combinations, going to physics graduate school, not going to physics graduate school. I had a student a few years ago who asked me if I would supervise her senior thesis, and she warned me in advance that she was intending to apply for law school. She was an excellent student, and I said, "That's fabulous you asked me. I would love to give you a great physics experience that you can carry forward and remember." And she went to Harvard Law School. So all types, yes.
So the student that sees this opportunity to add a second degree in the green physics, they then must take some additional physics courses that they otherwise wouldn't, or perhaps do a physics thesis that they wouldn't do. How much added requirements are they taking on?
It varies with the student, but our students are an ambitious lot. I think perhaps some of them are maybe even planning to explore the physics second degree option at an earlier stage. They just don't commit to it until they have confidence they can achieve it. Right? And that confidence issue is important. I think it affects perhaps our success with undergraduate women and other students from underrepresented groups, underrepresented minorities who have fewer role models, less confidence in themselves because they don't have the experience that a lot of the male students have of aggressively leading the pack and having so many role models open to them. So really that flexibility has changed the culture of the student program in a way that it just invites more students in. Good. Let me, sure, yes, one more.
How does the ability to double major more easily increase the class sizes substantially? Or are you just now having the same people who are taking all these physics courses as engineering students actually just applying for this?
No, we see some dramatic classroom growth. I don't have the statistics here, but probably we have about twice as many students taking our junior quantum mechanics courses as we did 10 years ago. Maybe more than twice. It's substantial. Here is the enrollment percentage of student population of women for undergraduates and graduates, just the total population. We have about 300 undergraduates now among all our classes. That's a huge number for an undergraduate physics program. And we have about 240 or so graduate students. You can see that about a third of our undergraduates are women, although that number is growing. It's going to increase. We can just extrapolate. And at the graduate level, we're currently at 18%, and we've been admitting classes with about 24% women for the last 3. So as students complete their PhDs, this number will grow towards 25%, and I hope eventually beyond. But the numbers are large enough, and the growth has been large enough. Perhaps it's not so visible over this 8 or 9 year period, but there's a difference between 12% and 18% in the graduate level. And this undergraduate number did jump up pretty quickly owing to the flexible major. And we're going to start to see some increased growth, as I say, for whatever reason in the last couple of years. Now, turning to the graduate student population, in 2007, our graduate students compiled a list of the percentage of women graduate students in various programs. When I showed this to my faculty, they said, "Wow, that's great. We're up here with Princeton." And then they looked to find Harvard and realized that the hierarchy was inverted. And so we did a lot of soul searching. This is when I transitioned to department head, asking what's at work here. In a few instances, you could identify this is the Howard-Georgi effect. For example, at Harvard, a previous Harvard physics chair who has made strenuous efforts over a couple of decades to improve the status of and increase the numbers of women in physics. And you can, in a few cases, associate names with other effects here. And of course, the hope is in the long run, there will be no named effect. It will just be that everyone will be taking advantage of the full population of available talent.
And are those just physics departments or physics?
They're just physics departments, although in some instances, like Stanford has no separate astronomy department. You have no separate astronomy department here. Yeah, these don't combine with astronomy because astronomy has higher percentages of women. That's right. Except at MIT and a few other places. So this was a concern, and you can look at your statistics and update them and think about the same and ask what are the differences here? Can we improve things? We looked at our admissions yield and the percentage of offers made to women and the fraction of those offers that were accepted. And we found, before I was the head, we only analyzed this data when I was the head, that women were choosing to come to MIT with a very statistically significant lower yield than men. And we had data going back considerably more years. This was statistically significant. And I was appalled in 2007 when I came in at the 20% yield. And so I made a strenuous effort. Well, really the graduate women made a strenuous effort and enlisted me to help them. And I brought in postdocs and women faculty and made an all-out effort. And we turned 20% into 70% the next year, which was very nice while the yield for men went down. So. But then the nice thing is that the yield for the men came back up and is almost as high as our admissions yield for women. That's terrific. I hope it continues. Yes?
Are there any financial methods to
No, we have not offered financial incentives, different fellowships, for example, for men or for women of any variety, although we do offer most of our incoming graduate class one-year fellowships. Okay. So really, I think this is driven by the students themselves who feel that MIT, for whatever reasons, is now a more attractive place to do physics as a woman graduate student. And I hear it talking with the graduate students. They're happier. They feel included in the sense of inclusion that I mentioned before. And those qualities may seem intangible, but I think that they do have tangible effects. Yes?
How do the incoming scores, GRE scores, GPAs, credit hours, everything of the admitted women compare to
Well, one distinction I know is that the international students, applicants, tend to have the very top GRE physics scores. And they are also preferentially male. If you exclude the international students, then I don't recall the numbers, but I don't believe that there is a strong difference between the men and the women, although I have to be cautious. I don't know the numbers at the top of my head. But the biggest effect is with the international students. Now, we don't use a formula. We don't have a cutoff. We don't say that you have to have a GPA greater than X or a GRE score greater than Y. We try to look at each case individually, and oftentimes, as in any admissions committee, you look at candidates and ask, does she or he have the qualities needed to succeed in our program? And we look at the course preparation, we look at the letters of recommendation, everything that you all do. I would say that we try to give consideration to students who may not have the preparation of a Caltech or a Princeton or a Harvard undergraduate preparation where they have all the same courses that we do at MIT and a very rigorous physics degree. There's a lot of talent that can be mined from students from smaller colleges who may not have the chance to take 3 or 4 semesters of quantum mechanics as an undergraduate. And so therefore, perhaps not score as highly on the exams, but have remarkable qualities of success in their research. If we think that they can succeed at MIT, we recruit them, male and female. Are there other questions? Another reason for trying to increase diversity is that we have a larger role, a national role, in educating leaders in science and technology. And here are some of our notable graduates of our PhD program, women, men of color. And Cherry Murray was the president of the American Physical Society, and now is the dean of engineering and applied science at Harvard. Ronald McNair was an astronaut on the Challenger shuttle, died in 1986. Shirley Jackson was the chair of the Nuclear Regulatory Agency and now is the president of RPI. All really outstanding physicists, and we're very proud to have them as graduates. And so what are some of the elements that go into this? Well, we've talked a lot about the curricular element because that gives a particular leverage for undergraduates. But I would argue that much of our success comes not just from the mechanical changes in the program, but from creating a more inclusive environment. And that involves working with all groups, from undergraduates, graduate students, postdocs, faculty, and staff, and thinking about recruitment, retention, mentoring, promotion, climate issues. So here are some of the thoughts that I presented to my faculty and also to my physics visiting committee, that recruiting more graduate students is a particular need because the representation of women and underrepresented minorities in that population is so small. It's far below some of our peers. We aspire, we compete with Harvard. You aspire and compete with us, with Harvard, with Stanford, with Caltech. We all should be aiming to get as much as we can from the available student population. We work to recruit and retain a more diverse faculty because the more role models there are in the faculty, the easier it is to recruit. And really, it just helps the success of the department, again, to bring in as much talent as you can. And there are very specific steps that I've taken here as head involving search process and mentoring. I've talked a little bit about climate and community. And another way to bring students into physics is to show them the value of a physics degree. So we have worked to begin to increase the number of underrepresented minorities in our graduate program by not only drawing from our program, from the top programs, but also from the students who come maybe from historically black colleges and universities or other institutions where they don't have the same course preparation as our students, but still have great promise. We develop relationships with these students at their universities through partnerships between our faculty and HBCUs, or in our case, not a community college, but a state university that serves many underprivileged and underrepresented students, UMass Boston. We recruit students at the National Society meetings, Black and Hispanic physicists, SACNAS. We develop relationships with these institutions by visiting them. And I've visited, together with several colleagues, a number of these universities in the past year. And as a result, they gain trust in our working with the students. They send them to our summer programs, and then we would like to recruit those students to graduate school. This is, in fact, sanctioned at a national level by the American Physical Society, which under Cherry Murray's presidency initiated a minority bridge program. You can read about this at the American Physical Society website. And we're working with the APS along with several other universities. Students recruit other students. This is a really powerful way of drawing students to your program. A couple of years ago, I attended the conference for undergraduate women in physics at Yale, and I just loved it. I loved being, I think, the only male faculty member and one of very few males in the audience of a bunch of excited women physicists. It was terrific. In fact, this year at MIT, we hosted this conference because our undergraduate students, mainly women, were also very excited about this and wanted to host the program at MIT. It's an annual event There are 4 regional conferences held the weekend of Martin Luther King birthday, so a few weeks ago in January, and there was one held at USC. Perhaps some of you attended that. This is a photograph of part of the student group from this year's conference. There were almost 150 undergraduates altogether, mostly women. You'll find a few male students throughout that audience. That's wonderful. I'll tell you an anecdote. One of our speakers was Margaret Murnane, a well-known atomic physicist at Gila and the University of Colorado, Boulder. She talked to the women about her research, but gave a preamble about her career path in physics. And she told the story of taking her husband, who is also a physicist, to a Women in Physics conference. There were about 30 women and her husband. He said he was so spooked that he wanted to just run out of the room. But then, he told her, I realized this is what you feel every day. That had a powerful effect on the male students in the audience. Recruiting and retaining a more diverse faculty is another way of working on this issue. And in addition to being close to the bottom of the list in graduate diversity, my department, we were at the bottom of the list in faculty diversity, at least gender diversity at MIT when I started as head. Yes? Please.
Has all that effort to recruit underrepresented minorities resulted in an increased number of undergraduates?
Oh, actually, yes. Let's talk undergraduate and graduate. At the undergraduate level, MIT has 23%, I believe, underrepresented minorities. That's Hispanic Americans, African Americans, Native Americans, university-wide. That's about roughly 15% Hispanic, maybe 14%, 8% or 9% African American, a very small percentage of Native American. In the physics department, 12% of our undergraduates are Hispanic American, but many fewer African American, I think 2 or 3%. I've been delighted to see a significant tick up in that in the number of freshmen and sophomores who are African American, and a couple of them are prodigies. They are really advanced, and we're super excited about having them in physics. Our physics classes, even they're taking graduate classes as sophomores. These are the kind of students whom we want in physics. At the graduate level, evolution is slower. We've not been running long enough in this kind of recruitment mode to recruit many more underrepresented minority students. But for sure, if you just integrate our effects over the last few years, we're above where we were 5 years ago. The APS goal is to roughly double the number of PhDs to underrepresented minority students. By the way, 2% of PhDs in the US every year go to underrepresented minorities. 2%. And they are about 28% of the domestic population. Now, factor in that about half or a little over half of PhD degrees in physics go to international students. So you should roughly double the percentages to compare with the domestic population. But it is still a source of great untapped potential. This year, perhaps some of you have noticed, we have added a wide open search category of general physics and astronomy because I felt it was important to not search narrowly in fields where applicants might look and question whether they fit. I want to look at all the talent that potentially could fit into our department, and I'm very pleased by the range of applications we have. I've been very proactive with our faculty in discussing things like implicit bias, in talking about the affirmative action procedures that I want the search committees to take. Our Dean of Science has done the same. They're getting it from all sides. And as a result, we're seeing greater diversity in our interview lists for finalists for faculty positions. And over time, that will have, I think, an effect on the outcome. One way to describe this is to charge the search committee to be a search committee, not a sort committee. Or make search a verb. Don't just wait for the applications to come. I subsidize our research groups to invite visitors, postdocs, even finishing graduate students who may be candidates for faculty positions or even for postdocs in a couple of years. And that's a popular way for us to get to see the talent pool and for others to begin to think about a possible track at MIT. Mentoring is extremely important because we don't come into faculty positions, or for that matter, graduate or postdoctoral positions, with all the skills needed for success. I didn't know how to balance my time. I didn't know how to focus my efforts. I didn't know how to write a grant proposal when I became a faculty member. Not many people do. And if we as a community want our young scientists to develop to their full potential, it's better that we equip them with these skills. We don't teach them in classes, but we can do it in a kind of a mentoring or apprenticeship model, a little different from what we do in graduate school. So we have formal mentoring of our junior faculty. We have a senior faculty mentor assigned in every case. We have a division head. Our department has 4 research divisions, and I, as department head, also play a mentoring role for our junior faculty. And I've communicated to the senior faculty that this is important because I ask them to report on their mentoring practices as part of their annual salary review process. Yes?
What are the mentoring activities that are prescribed?
I won't go into detail here, but instead refer you to our MIT Physics website, which you can just Google MIT Physics. And when you go to our main website, you will see a column called Policies or Procedures. I've forgotten. But if you click on that link, you will see lots of information about our formal mentoring program. You'll see mentoring guidelines that are available to the faculty, advice for new faculty, etc. Are there other questions about this? Okay. Improving the climate and community is completely important, very, very important. Again, intangible, but just you can see that people are happier, they're more productive, they share their excitement with colleagues, they draw students into physics. We assessed some of our climate challenges a couple of years ago with the help of the Committee on the Status of Women in Physics of the American Physical Society. Here's their webpage, and close to this is the Minority in Physics webpage, where you can find about the APS Minority Bridge Program. I congratulate the department here in signing up for an APS climate site visit in this coming year. I think it could be informative for you. It was helpful for us. And then there are lots of little ways that you can show people you care. You can engage people in discussions about how to improve climate. Listening to your faculty and students is incredibly important. I told you about the importance of listening to our women graduate students. For me, I'm pretty visible, but not the only one in physics or other departments who makes a point to reach out to students and others from underrepresented groups. A few weeks ago, we hosted the Northeast Conference for Undergraduate Women in Physics. A week ago, we held actually now an MIT-wide diversity summit on campus. And then there are lots of other kinds of campus advocacy roles that I and others pursue. This was the image of a group of us at MIT who attended the National Society of Black and Hispanic Physicists in 2008, I believe it was. And I've taken this as kind of a central image, a theme of having a more colorful physics community at MIT. Finally, you want to share the excitement and the value of doing physics with your students because we love what we do in this field. We were drawn to it because of the excitement and the passion of learning about the universe. Even if, with that training, some of us and some of our students may have gone into other fields. Seems now I'm becoming a bit of a management person, for example. So I've made an effort to find some stories from my faculty and students that I thought might resonate with physics students. And I share these with physics students. John Little is a physics graduate from MIT. actually doing operations research for his PhD degree, mathematical physics, and has become one of the leaders in the U.S. of quantitative marketing. And his marketing line for us is, I prefer to hire physics majors. One of our recent graduates, Virginia Corliss, went to Cambridge and got her PhD in astrophysics, but realized then that she wanted to pursue a career in science policy. And so she became a congressional fellow, serving on the Senate Energy and Natural Resources Committee, finished up that, organized by the APS and the American Association for the Advancement of Science, and now is pursuing a career in international energy policy. This is relevant for our students. They care about global energy concerns, and a physics degree helps you to do this. Finally, I'd heard stories that a number of MIT faculty outside the department had physics degrees. I would go to faculty mixers, and people would say, oh, yes, I have a physics degree. Oh, yes, I have a physics degree. They're proud of that fact. And so I went through the MIT faculty roster, roughly 950 of them outside of the physics department, and discovered that 11% of those faculty have physics degrees. Actually, a good number of them from MIT physics department. And these are faculty outside of physics doing such things as the head of the electrical engineering and computer science department, a fluid dynamicist, undergraduate degree. In her case, both undergraduate and graduate degrees. Hers was an undergraduate degree, professor of archaeology. That's really cool. Brain science, Media Lab, PhD as well as undergraduate degree. This really resonates with the students. They look and see their popular teachers across computer science, mechanical engineering, wonderful career opportunities there. A physics degree helped these faculty to achieve their positions. I'm sure you could do the same with your faculty listing here, and it might help you recruit more students to the major. Finally, the intangibles are important in communicating a sense of the excitement and the vision of what we're trying to achieve. And so I communicate pretty widely. You actually find this on my website. A vision statement to make MIT the top-ranked university in science. Sometimes I will say science and engineering. And the best place to work and study for everyone. It's a bit of that inclusion ethic here. And I charged my faculty with this mission: to increase the diversity of its faculty and student populations, to improve our excellence and better serve the society that supports our work. Again, that's on our website as a formal statement of our department's mission. And I believe we're making some strides. These are long-term goals. Changing the face of the faculty is a 30 or 40-year project, but you only achieve a journey of 1,000 miles by taking the first step. So with that, I'll stop and take your further questions. Thank you.
Maybe I'm mistaken, but I thought I'd seen an article in Physics Today a couple of years ago that said that the percentage of women in physics in the U.S. has not been increasing for many years. Is MIT actually doing better than the rest of the physics department?
We are now doing, well, at the undergraduate and graduate levels, we're now doing better than the national averages for physics departments, yes. At the faculty level, no. We're actually, by now, no longer at the bottom, but probably in the bottom half of physics departments. Change is slow, particularly at the faculty level, but not so slow at the student level. Yes?
Yeah, you talk about undergrad, grad faculty, but you can't miss the postdoc part. There more or less is a woman, I mean, very critical period for a woman. Most likely it might be the first time or the second
Right.
time. And so it's when the woman decides what
Yes.
they want to do about it. So MIT doing something to help postdoc.
Thank you for asking that question. I didn't talk about the postdoctoral group. It's a really important question. The reason I didn't is because at MIT and most places, postdocs are not associated usually with the department. There are many varieties of postdocs. There are portable fellowships. In the case of MIT, most postdocs who do physics are not appointed through the physics department, but rather through something like the Kavli Institute for Astrophysics and Space Research or a laboratory for nuclear science. So even for us to assemble a list of physics postdocs has been a real challenge. I managed to do so. So I know the percentages of women, and I meet with the postdocs as I have with graduate students, and we're trying to increase the community feeling, inclusion for postdocs in many ways, but it's a widespread problem. And as a result of taking interest in this, I'm now on an MIT committee to analyze survey results for a new postdoctoral survey and recommend strategies to improve the quality of life for postdocs. I completely agree with you. That's a pivotal time for those who want families, men as well as women, and I think we ought to be doing more. The University of California, Berkeley has a Center for Policy and Law that has a couple of influential studies on that, showing from the UC, University of California postdoctoral surveys that women especially are concerned about balancing family and an academic career. I think we have to do a lot more to address that. We'll come back.
I had to go to a conference, and my baby was 6 months old, so she had to come with me and obviously breastfeeding. And what I was asking to my chair, so can I have some fun? And he said, no, just eat less and ask for the maximum per diem, so we can cover the. So sometimes also, I mean, there can be a really physical task from the university saying, okay, if you need some financial support for conferences, for traveling, we can help you that. But the fact that there is nothing available is sometimes tough to travel.
I agree. I hope everyone heard that. And most universities don't have policies that are very inclusive of postdocs. We don't. We tend to handle those on a case-by-case basis, and it would be better, I agree with you, to have wider policies. Perhaps with time we will, but thank you. Over here, yes, first one.
A lot of us know that if we're talking about the gender gap, so to speak, in physics, it's much less than in the U.S. and France. France is much better. Can you comment on that in the context of things? I know they have a well-developed press system, which is helpful for us.
Some people call it the Marie Curie effect. I've spoken with a number of French scientists and who have speculated about this and pointed out that it helps to have role models, and a very influential Nobel Prize winner. There aren't very many women Nobel laureates in physics. Yes, and it's not Marie Curie. Actually, one has to be very careful here because I know Marie Curie got 2 of them, and is one of them in physics? Well, there is another Nobel laureate in physics, female, Maria Goeppert-Mayer. Okay, right. But to amplify on that, the country with some of the greatest gender diversity in the sciences and physics is Turkey. Okay? And some of the least gender diversity in Europe, in the Scandinavian countries, which in fact have a lot of women in positions of power, presidents, prime ministers, and so on. And I speculate it may be because they see role models of women going on into successful careers in politics and leadership, but not in physics. Yes, you in the back.
Comment on that? I looked into that a little bit as well, and I think another explanation is just what's the cultural role of a professor in a country. And in countries like Turkey or Spain, often the military career is more prestigious, and that's why a lot of men follow that. While the professor career is not as prestigious, you looked at in the culture, and that's why in Germany, for example, it's opposite. So I think there are many different issues. It's not as easy to say, there's a role model.
Thank you. Thank you. I'm going to come over here first and then back.
One of your slides, I think it was the percentage of women in the percentage of women graduate students, percentage of women undergraduate students. physics, and there was a factor 2 difference.
Yes.
In that percentage.
Correct.
Is that true across all universities in the country, and why is that?
Let's see. Across all universities in the country, it is less than a factor of 2. We're relatively more successful with undergraduates at MIT, and frankly, I think that's because change happens faster at the undergraduate level. The national statistics are a bit out of date, but they're about 23% women PhD graduates per year in the U.S. and 23% bachelor's degrees, and about 11 or 12% PhDs. So perhaps it's not different from the factor of 2. We're just a little bit higher. Yes, you have a comment on this point?
Yeah, I just recently applied to a lot of graduate schools for my PhD, and MIT's application doesn't address diversity, I think, personally, because a lot of schools, like Cornell, for example, had a diversity statement. MIT just had a 500-word personal statement about anything. And it didn't really have, anything, it didn't show that they were very interested in diversity for the graduate school application.
Would that have made a difference in your perception about the program?
Yeah, I did, because there was not only a 500-word personal statement. You can't say your background, you just have to say what research you did, which is more important as a graduate application. But for different schools like Cornell or Northwestern, they had a separate application, not application, but separate,
right.
Check-in box where you have to write your personal statement. And I think it was more attractive for me because it made me feel that, they actually want me as a grad student.
I'm grateful for your mentioning that, and I will look into it. Thank you. Yes. Thank you.
Affirmative action promotes diversity in education. What do you think about something similar to that for specific areas of study?
Study or research or education? Can you be more specific?
Education.
There are legal issues associated with affirmative action, as the state of California well knows, and the state of Michigan, because there have been ballot propositions, laws, and court cases that limit the ability to use affirmative action to redress issues of imbalance, whether they be racial or gender. We're not limited in the same way in the private institutions, so we actually will sometimes use the words affirmative action without concern of a lawsuit. But we have no formal requirement to do so, and there's certainly nothing beyond the equal opportunity statutes in the U.S. law that compels us to do so. It is really our sense that we will improve our excellence by attracting a larger pool into physics. Frankly, I think that's the best motivation of all. Yes?
Yes, I'm curious with your great success in increasing the number of women applicants, what to enroll in graduate study in physics. To what extent do you think that by making MIT more attractive, you have more successfully competed for the pool of sort of obviously qualified women? And to what extent have you been found candidates who might have some not so obvious talent?
That's a tough question. I guess to rephrase it, how much are we drawing students from let's say, the obvious quote-unquote stars? And how much are we better taking advantage of the broader population? I don't know. As I said, we don't offer special fellowships to women. And yet by offering fellowships to the majority of first-year students, we've had a better yield in those at the tops of our preference lists, who are very often women, by the way. In my own field of astrophysics, we compete very strongly with places that are higher ranked, and we lose many top women, who in fact are at the top of our application lists. So we could probably work harder to in ways to recruit a larger percentage of stars in that field. But I don't make a distinction. I think any student we admit, we believe that they can succeed. Once they arrive, I'm committed to their success. I want my faculty to be invested in the students. I want them to be available as mentors and to help students through our difficult general exam process. That's it. It's not about making a distinction between one class of students and another. Yes?
When you talk about imbalance and underrepresented groups, do you have in mind an ideal level of representation?
Ideal is hard because we don't operate in a vacuum. There's a context here. Perhaps in the long run, my ideal is that our population become better educated as a whole, that a larger percentage of underrepresented minorities graduate from high school and go on to college. You've listened to Obama's speech, perhaps. I have, and I share his vision for the importance of education. Until that happens, it's artificial to set any kind of expectations numerically. I just saw an opportunity for attracting more students to MIT who were choosing to go elsewhere because they didn't find us attractive. That required no quantitative comparison aside from looking at our peers. And I hope that you'll do the same calculus and realize that you will compete better and therefore be more excellent through increasing your efforts for inclusion and diversity. Here first. Phil, and then you.
One of the complications we have at the university, and I think with many public institutions, is that it's very difficult for us to get foreign students to come because it costs so much more.
Right.
It's very difficult to get out of state to cost so much. So we're inherently limiting our pool of readily accessible.
To 40 million people in the state of California.
But it does change the mixture of who we can admit. I don't know to what extent, so we'll begin this question for you. To what extent is your foreign admissions and the out-of-state admissions more heavily represented in both minorities and women?
Oh, I said it's lower. Our international population is predominantly male. And by definition, there are no U.S. underrepresented minorities in that population. Although, of course, we bring in students from Spain, from Latin America, and we and the dean and the provost discussed when do these students count as underrepresented minorities. That's irrelevant. Okay, the numbers game is not what it's about. It's looking at the pool of talent and trying to grow that. And we're absolutely going to recruit a student from Peru or from Brazil or Colombia or Spain or Thailand or Kenya, Ethiopia, who can thrive in our physics program. Not many. We do get some applications, and we've had some in the past, but not at present that I know of. Here.
Do you have any information on the economic background of these students? And is there a selection effect against folks of lower economic status communities, as well as
well, I know from my visits to HBCUs that not all students are aware that you get paid to go to graduate school instead of having to pay. Now, I realize you may not get paid enough, but it's a very big difference to students who are told by their parents, we have just invested our life savings to send you to college. You now have to repay that debt to society. If they know that they can come to a top place and get a PhD degree and thereby repay more to society, perhaps more of them will come. And there is still a lack of information about this in some of the minority-serving institutions. So, yes, here.
So you showed us the 10-year history. Now, when Bob Bertschinger was at MIT in the 90s, there was a top-down approach
Right.
To really increase female faculty.
Absolutely.
So is there a connection here? And my question is, so is there room for a top-down approach? Because we kind of talk mostly about within the department.
Yeah. That's a really important question, and it's one that I think about and am involved in because my efforts, of course, are noticed in the wider university. I do things, I speak with and advise other department heads and talk with the deans about these issues. First of all, there was Nancy Hopkins, professor of biology at MIT, has analyzed the faculty trends and found significant effects of Bertschinger's efforts, and then later in individual departments, individual department heads, who made a strong effort to increase the diversity of the faculty. And as a result, there are many more women faculty in science and engineering now at MIT than there were 15 years ago when the Women in Science reports were first done. As a matter of fact, I'm working with a group of women faculty to, I'm chairing the organizing committee for a symposium on women in science and engineering at MIT that is part of a select group of symposia celebrating our 150th anniversary. And in preparation for that, the women are repeating interviews with each other. Nancy Hopkins and others are interviewing senior faculty. There are interviews of younger faculty. And we're trying to get a sense of progress and remaining problems to be addressed. Certainly the numbers are very, very different. I'd say that the sense at MIT is that the numbers issues have shifted more to underrepresented minorities. Last year, MIT had a top-down report called for by the provost called the Faculty Race Initiative, which identified numbers problems and barriers to the progress of underrepresented minority faculty and students. And so there's a lot of attention being focused on that. And while the populations are different, some of the key issues are the same. The inclusion elements, the fact of respecting colleagues. A lot of what I've heard from women faculty, and I've heard through Nancy Hopkins, is that not everyone feels valued by their community and their colleagues. And it has a wearing effect on faculty. And so I feel it's important for us to be a supportive community for everyone. As I said, not just the faculty, students, postdocs, staff, and that promotes the excellence of the institution as a whole. I think we've got a good environment in the physics department, and I know that the other science departments at MIT have also made efforts, and they are showing gains. The biology department has tripled the number of their underrepresented minority PhD degrees since, I believe, 2004, 2003. That is really impressive. We don't have such gains in physics. Yes? The question that I've asked myself, because I don't want to step down his head at some point and just have the system spring back to the previous equilibrium. And so I've invested some time thinking about how do you change the culture. That involves not only setting an example, but empowering the next generation of leaders and empowering the students so that there will not be an option to go back to a less inclusive and less friendly environment where there is less focus on these issues. Time will tell. I think we've seen an increase in the numbers of women and an increase in their satisfaction, so I don't think we can go back to where we were 10 years ago. It's not an option. Mm-hmm.
So what was it about that area that makes you so important that you think? Because that might be relevant to our students.
Yeah. I was born in the San Francisco Bay Area, but when I was 8 years old, my family moved to Chino, California, which is a relatively small town east, about 35 miles, 40 miles east of Los Angeles. And at that time, it was a farming community with migrant workers who then were becoming incorporated into the population. So it was I lived in a Hispanic neighborhood. Our family was the only white family in that neighborhood. So certainly I was very used to a multicultural, multiracial environment growing up. I was driven to do physics, but aware of the environment in which I grew up. And probably that does have an impact on my thinking about the bigger picture. And likewise, you're in a state with a large Hispanic population. Presumably you have a large fraction of undergraduates here from that Hispanic population. you should want to recruit those students into physics, whether they go on to graduate school or not. Yes?
I totally agree with you about the importance of mentoring, but I wonder what you say to people who say, if they're good, just throw them in and let them try it, and then, talented one will succeed and the other ones weren't going to succeed anyway. Because you hear that a lot, and I don't know how to clearly think, that's not correct.
One thing I say is, that almost ruined me. And I won't relate my story here. I'm being videotaped. But I quickly felt that since I learned a lot struggling with the sink or swim culture, that perhaps there was another way. And so when I had the chance to supervise junior faculty and be responsible for some element of their evaluation and career advancement, I thought, let's try as an experiment to invest a lot of effort into mentoring. And I've gotten very, very tremendous positive feedback from the faculty, from their success, and now I've seen that in other instances as well. Invest in people and provide them the skills the same way that you do the parents here for your children. Our students are no different.